Okay, so today we're going to be talking about how to graph inequalities in two variables. So our whole study of this chapter has been on inequalities. And so now we're actually going to get to how you graph them, not on a number line, but rather on a coordinate plane. And so if you look up here, I have y equals mx plus b. What form of an equation is this? Slope-intercept. Good. And so what is the slope? M. There you go. Good. What is the y-intercept? B. So the reason we looked at that is we're reviewing now. And so when we look at our first example, we kind of already remember about slope-intercept form. And on that first example, that actually isn't in slope-intercept form. So I'm going to need to put that in slope-intercept form. So first step, I'm going to subtract 3x. My goal for slope-intercept form is to solve for y. Get y all by itself. On the left side, I'm left with negative y. I have a less than sign, and then I have negative 3x plus 2. What do I need to do now in order to solve?
Divide by -1.
Perfect. Divide by -1. Now, you just said a key word, negative. Now, when we divide by that negative number, what do I need to do?
Change the sign.
Change the sign, so it is now a greater than sign. Okay? Any questions so far? What is your slope in this equation? Or in this inequality, sorry. 3. What is your y-intercept? -2. So what I need to do now is I need to graph that line. Now, I'm going to go ahead and put a dot at -2 on the y-axis because that's my y-intercept. And then I've got a slope of 3, which means up 3 over 1. Up 3 over 1. Now, before you draw a line in, we need to talk a little bit. I am going to look at my inequality sign. If my inequality sign does not have an equal to part, means the little line underneath the inequality, you have to use a dashed line. If it has an equal to line, you use a solid line. So in this case, am I going to use a dashed or a solid?
Solid.
Dashed because there's no equal to. Okay, it's kind of like the open and closed circles we did on the number line. Oops, let's try doing that one again. Okay, there we go, a little bit better. Now the thing with an inequality, if you remember when we graphed on a number line, we then shaded one side of the line or the other, right? So we're going to do the same thing here with the coordinate plane. I'm either going to shade in region 1 right here, which is on that side of the line, or region 2 over here. Now the question is, what side do I shade? This is what you need to do. You need to pick a point on one side of the line or the other. Doesn't matter. A good rule of thumb is to try to use something with a 0. So I'm actually going to pick this point right here. What point is that? 0, 0. And now I'm going to plug that into my inequality. So I'm going to plug in 0 for y and 0 for x. Now when I do that, on the left side, I get what? 0. I still have my greater than sign. On the right side, what is 3 times 0? Minus 2 is -2. So is this a true statement? Okay, is 0 greater than -2? Is it? Yes. So I am going to shade on the side that has that dot. Because since this is true, that means every point. So in this case, I'm just going to shade region 1. What do you do with region 2? You leave it alone. You don't do anything with region 2. And that is your answer. What this means is any point that is shaded in with the green shaded, that will satisfy that inequality. So every point here that's shaded will fit that inequality. We'll make it true. Let's look at another one. So now this one's nice. Why is it nice? Good, it's already in slope-intercept form. What's your slope? 1/2. What's your y-intercept? 3. So I'm going to start my graph, and I'm going to put a dot at 3. Slope of 1/2 means you do what? Up 1. Up 2. Good job. What type of line am I going to use? Am I going to use a solid line or a dashed line? Dashed because there is no equal to part. Okay, so dashed line, let's go ahead and draw that in. So now I need to figure out which way I need to shade. Once again, I have two regions. I have this region up here, and I have this region down below. So I need to pick a point. It can't be on the line. It has to be on one side or the other. Good one to use, once again, would be the 0, 0. So I can plug in 0, 0. So on the left side of my inequality, when I plug that in, what do I get? 0. What do I get on the right side? 3. Is that true? So since it's not true, what region am I going to shade? 1 or 2? Okay, where's 0, 0 at? What region is it in? 2. Is it true here? No, so this is the part I don't shade. Okay, so when it's not true, you shade the other region. Okay, we've got 2 more we're going to look at today. So, what I'm going to do with this one is something a little different. Remember how we're used to seeing y on the left side and everything else on the right? I'm just going to flip this inequality. So what is my inequality going to be that I put between those two? Less than sign points to the left. So now, what do I get m to equal? 1. That's the number in front of x. Okay? What's the y-intercept going to be? -1. So I'm going to put a dot at -1. And I've got a slope of +1. What does that mean? Yep. What type of line am I going to use here, guys? Dashed. So I've divided my coordinate plane into 2 regions. Now just for kicks, let's use another point other than 0, 0. Okay? So I'm just going to pick this point right here. What are the coordinates of that point? 0, 1. So that means I'm going to plug in what for y? 1. What am I going to plug in for x? 0, because that's my point 0, 1. So let's write my inequality now. I end up having 1 on the left side. What is 0 minus 1? -1. Is that true? It's not true. 1 is not less than -1. So what region am I going to shade? 2. Very good. So what that means is any point that is shaded in will satisfy this inequality. So inequalities usually just don't have one solution. They usually have a range or a wide variety of solutions. Our very last one that we're going to look at. We got a little work to do on this one. What should I do first? Subtract 2x. Very good. So I end up having 3y on the left. On the right side, I have negative 2x plus 18. What should you do now? Divide by 3. Do I reverse the inequality? It's not negative, so the answer is no. Nice job. So negative 2/3 x plus 6. All right, what's the slope? Negative 2/3. Good job. Caught the negative. What's the y-intercept? 6. So I'm going to put a dot at 6. And I'm going to graph a slope of negative 2/3 from that point. So what does that mean?
Down to 2 over 3.
Good. Down 2 over 3. What type of line do I use? Solid. Nice job, because there is an equal to sign. I use a solid because of this right there. Okay. Now I've got two regions again. We'll do this. So let's pick a point. What point do you want to pick? 0, 0. If you can, that's always a great point to use. So let's plug in 0, 0. There are two places I could plug this in. I could either plug this in the original if you wanted to. So realistically, I could plug it in here. Or I could plug it in this one. It doesn't matter. Okay, let's plug it in the top just to show you that that works. If I plug it into the top, what do I have on the left side? 0. What's on the right? 18. Nice job. So is that true? Is 0 greater than or equal to 18? No. So what region am I going to shade? 2. Nice job. So are there any questions over what we've discussed today? That's pretty much what you're doing. If you need graph paper, you know it's in my top drawer. Page 320, you're looking at numbers 12 through 23.